Welcome back to episode number 11 of this tutorial series / crash course on ROS 2. You can find the series playlist in the description. And let's get started. So in this tutorial, we are going to create a service client with Python. And to see what we need to do, let's actually come back to the application with the turtle controller that we have. So let's run, so ROS to run turtle sim with turtle sim node. Okay, we have the turtle here, and then we have the controller, ROS to run turtle, no, actually my package, my robot controller with turtle controller. So for now what we have is the turtle is correctly controlled to move around and not hit the wall. What we want to do is we want to kind of split the screen in two and say that on the right we want the color to be, let's say, red, and on the left we want the color to be green, so the color of the pen. All right, so we wouldn't want to modify the color depending on if the turtle is on the right side or on the left side. And how can we do this? Well, ROS2 service list, we have just actually used, so this one, the turtle one set pen service. So we have just used this one in the previous tutorial to explain what are services. And so that's the one we are actually going to code. So we are going to code a service client inside our turtle controller so that we can modify the color of the pen depending on where the turtle is. Okay, so let's actually do that. I don't need to create any new node or anything. I can just go back to, so let's go to the source folder of the ROS2 workspace and let's do code dot, and let's go back to the code. So the turtle controller here, and so that's where I am going to create the service call. And where are we going to create the service call actually? Well, we are going to call the service from the pose callback, okay, because we need to call the service depending on where the turtle is. If the turtle is on the right of the screen, which means that actually the pose x is greater than 5.5, which is the middle, then we're going to choose the color red. If it's on the left side, we choose the color green. And so we will need to call the service, so to create a client with a request in the pose callback, okay? And to do that, I'm going to create a new function, here, a new method in the class def call set pen service. Okay, because we will have a few lines of code to do that, so I'm going to create a method that is specific just to call the service. Okay, and let's do self, and then let's put all the parameters we need, so RG, which is the middle, and we're going to choose the color red. If it's on the left side, we choose the color green. And so we will call the service, so to create a client with a request in the pose callback. Okay. And to do that, I'm going to create a new function, a new method in the class def call set pen service. Okay, because we will have a few lines of code to do that, so I'm going to create a method that is specific just to call the service. Okay, and let's do self, and then let's put all the parameters we need, so RGB width of. Okay, how do I know that? Because if you do ROS2 service type, width of. Okay, how do I know that? Because if you do ROS2 service type with the set pen, okay, where do I have nothing? Okay, because, well, the service actually doesn't exist. I need to run ROS2 run turtle sim node, then this should be better, and ROS2 interface show with that we have RGB width and off, so those are the 5 parameters create a function, and I just send this as the parameters, and then what do we need to do? We need to create a client in the code. So client is equal to self. So self is okay. We did a. We are going to do is service type. What is the service type? The service type is turtle sim srv set pen. So we are going to do from from turtle sim dot srv. Okay, we did msg for messages for topic, and here for service we do srv. Import set pen. Now we need to make sure that we have the dependency to turtle sim, but we already added it before. In the package.xml we have turtle sim, so everything is good. So I have set me to provide him the with client. It's gonna be better. And that's it for the creation of the client. So now we have a client. Well, actually, we have nothing. We just have an object representing the client. What we'll do is we'll say, let's say we want to wait for the service. Okay, we don't want to call the service if the service is not up. Because if you call the service and the service is not up, well, you're gonna have an error. Here I'm gonna do while, and here we're gonna do self.getLogger. We're gonna log something, and instead of info, I'm gonna use one. Okay, one is gonna 1 second if the service is up. So this is just gonna return immediately, and we can continue. But if the service is not up, after 1 second, we are gonna print waiting for service, etc., etc., until the service is up. Actually, the request, nothing really fancy here. And then, well, we're gonna call the service. Okay, we have the client, the service is up, we have the request. Now we can call the service. So we can do client call async. So this will call the service in an asynchronous way. What does it mean? It means that it's gonna return immediately. If you call it just with the call like this, it's gonna call the service and then wait, so block right here until the service has replied. But if you do that, you may have some problems with you. This is actually going to give me a future bit. That's what it is. We add unit, import it. So from func tools, import partial. That's one thing you need to import. Okay, with Python func tools and partial. Then we put future.add down callback with partial self callback set pen, and this is gonna call this method when the service has replied. this, what we do is we do response is equal to future, so that's the future we get here, dot result. Also, I'm going to add this inside a try and except block, because we might have a service exception. I'm just going to do except exception as E. And if I get an exception, I can do self.getLogger. And here I'm going to use error. Okay, so that's yet another level of logs. Okay, we have info 1 and error. And I can say service call failed. And I'm going to use this syntax with R here and then percentage E comma inside parentheses. So that's a specific syntax, but that's just how you can print the name of the call object. Nice. So if every ROS2 interface shows, then by doing future.result, you're gonna get the response. And here, well, I do nothing with the response. Why is that? Because here with ROS2 interface show, you can see that we have this for the request, and then dash dash dash, and we have nothing in the response. So if you add something in the response, for example, with the add to int server that we have used previously, you could, for example, do response.sum, and that would be something you can use in this node class. Okay, you could use it to do whatever you want. You can process the response and do anything else you want. All right, so now we have the syntax for the service call. And this, well, basically this is gonna be almost the same every time you call a service inside a ROS2 Python node. Now, well, let's actually call this service, because we have a method, but we don't use that method. Where are we gonna use it? Well, we're gonna use it in the pause callback. So what do we do in the pause callback? We get the pause, and then depending on the pause, we send a different comment. We're not gonna change that, but after we do this, we're gonna also check where is the turtle. So depending on the X property of the pause, we're gonna change the color of the pen. So for example, if X is greater than 5.5, so actually pause.x. So we know that the middle point is 5.5. So everything on the right of the window will be more than 5.5. Everything on the left will be less than 5.5. So if it's more than 5.5, what we can do is to do self.call setPenService with, so we want it to be red. So let's do 255, 0, 0, and then width, let's put 3, and off, let's put 0. And then else self.call setPenService with 0. So 255 for the green, 0, 3, 0. All right, so right side of the screen, red, left side of the screen, green, as simple as that. And maybe we can also add a log, self.getLogger.info, set color to red. And let's do the same here, self.getLogger.info, set color to green. All right, so we know when we send the request actually. If you want, you could also add some logs in the call setPenService and also in the callback, so in the try block, to see when you get the response, when you send the request, etc. Good, so this should work. But I'm gonna add something else, because, well, now the question is how frequently this is going to happen. For now, we didn't really worry about that, but now we should. Why is that? Because, well, when you publish on a topic, you can publish at very high frequencies. For example, 100 Hertz, 1000 Hertz, that could work also. Even a few thousand Hertz, sometimes you have some topics that are published, we call it, in a punctual way. So it doesn't necessarily mean that let's have, so Turtle Sim is running here, ROS2 topic list. We have the pause. How frequently do we receive a pause? Well, that's a good question, and we can get this with ROS2 topic Hz, okay, for hertz. That's gonna give us the frequency of the topic. Let's do this, and it's gonna listen to the topic. So let's wait a bit and let's do Ctrl+C. It's gonna listen to the topic and then publish the average rate, which gives you an idea of how frequently you get some messages on that topic. And you can see we have about 60 messages per second. So 60 Hz. With this code, we would call the service. What can we do to change the code from left? Turtle 5 x lower than 5. Let's create here self previous x, and let's just put 0 as an initialization value. Okay, and we're gonna do if. So if the pause is greater than 5.5, okay, and we're gonna do if. So if the pause is greater than 5.5 and self previous x is lower or equal than 5.5. Okay, so it means that before the turtle was on the left and now the turtle is on the right. Then we change to red. And then else, I'm gonna add else if actually. So not else if, but elif with Python. Pause is lower than 5.5. Actually, let's use lower or equal here. And self.previous x greater strictly than 5.5. So this means that it was previously on the right side and now it is on the left side, and then we want to change the color to green. And of course, we need to do self.previous x is equal to pause.x. Here and also here. Self.previous x is equal to pause.x. So that's a very quick way to solve this issue. Maybe there are different logical ways to do that, but this is quick and easy, and that's gonna be enough for this tutorial. So we initialize the previous x to 0, doesn't really matter. And then when we go from left to right, we set the color to red. We also save the previous x, and we do the same when we go to the other side. So that if we stay on the same side of the screen, okay, so if we stay on the left, we are not going to call the service. If we stay on the right, we are not going to call the service, only when we cross the middle. Okay, I'm gonna save this, and this should be it. So actually, let's find out and let's try. That's the only way to know. Let's kill everything here. Clear. Let's do source -rc because I'm gonna run the script from there. I'm gonna run the controller from there. Here, let's do ROS2 run turtle sim with turtle sim node. Okay. Here we don't need that screen. And let's run, so ROS2 run my robot controller with turtle controller. Let's see what happens. Okay, and we have an error, which is this is not supported between instances of pause and float. Let's find out with the code. Yes, actually, it's pause.x. I forgot the .x. So of course, I can't compare a pause with a number because that's something that's different. Let's try again. So let's run this and let's try this again with source-rc and run the controller. Okay, you can see it's red, and then it crosses the line and it's green, and we have a log too. It crosses the line and it's red, and you can see set color to red, and then set color to green. All right, and then again and again. I'm gonna leave it just a bit so you can see what's gonna happen at the green hitting the thing as on the node. I hope you enjoyed this